So I am going into further sections of my Chapter 8 review before the final exam of the Mathematics 308 course. And of course, now that we have learned that segments go on to form rays and lines, when they intersect, they create angles, and therefore we can measure those angles. They can be recognized as being measured in degrees, which go on to form, when vertices come together, we have all those different angles. They come together to form closed figures known as polygons. And now our two most recognized polygons, they can be classified, of course, by the number of sides they have. And I'll go later on in the chapter there and give a basic name of some of the side shapes that are beyond the two most recognized, which we have here. Different types of a four-sided figure is our most recognized, and we also have a three-sided figure here, which is another most recognized figure. You can go on to Google some of these other shapes. We know that an octagon, of course, has 8. That's the most common, and of course a pentagon is probably the next common. And you can go on, and I will, like I said, I'll make a list. You can go on to Google and look and see what these shapes look like, and you can get some pretty interesting art visualized out of that, obviously. So our two most recognized here, a four-sided figure is called a quadrilateral, meaning that 4 vertices come together and we've got 4 sides. That's my Star Trek logo there. So we've got 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And of course we recognize this as a trapezoid. We've got a diamond shape here, quadrilateral, a square, and a rectangle. But then our next common here is a 3-sided figure called a triangle. And remember that I'm going to go in here to show you that this little sign here is kind of like the universal symbol that signifies that this is a measurement. If there's not a number present, we will use these by showing like you could use these as an equal length. Of course, the triangle has 3 sides, so we can only have 1, 2, and 3, and that goes on to show that there are ways that we classify triangles. Now, as you recall, our angles that we can have a right angle, acute angle, and an obtuse angle formed out of a triangle. Remember, our obtuse angles open up greater than 90, so less than 180. And our acute angles, of course, are less than 90, greater than 0, and the right angles are our perfect 90-degree angle. So we have those 3 types of triangles that we will recognize, and then we can go on to classify. If there's a measurementation present, we can classify a triangle as either equilateral, meaning that all 3 sides are the same, and then we also have a scalene, meaning that the 3 sides are different measurements, and then of course we have isosceles, meaning that there are 2 or greater sides. 2 or more sides that are of the same measurement. And if you're kind of retrospective, this would probably be a pretty good IQ question to ponder upon, but a rhetorical question, or something that the caterpillar or something from Alice in Wonderland would say. But now that we can recognize equilateral and isosceles, are all equilateral triangles isosceles triangles? Well, yes, because an equilateral triangle has 2 or more greater sides. That's going on meaning that not all isosceles triangles can be equilateral because, of course, this only has 2 equal sides. So that wraps up our different types of triangles that we can classify these types. Of course, we've got the quadrilateral here, and the triangle are 2 most common types of polygons, and of course, polygons are classified by the number of sides they have.